guys, moving on to the Hooke's law graph. We have the graph here. So our graph will be plotted in a way that we will be having our force against extension. The force is on the y-axis and the extension is on the x-axis. But again, remember, in other books or where you will be reading, you might find that the extension will be labeled with a different variable. Say E, like we did first, or maybe D. It will depend on the source that you are using. So let's go on. So we are saying under the graph, the Hooke's law graph, we are having the area. The area under the graph will denote the energy stored in the spring, either being before it's compressed or after being compressed or when it's stretched. So again, our main focus is on the spring constant. This time around, we are going to use the graph to find the spring constant. So from the graph, how are you going to calculate the spring constant, or how are you going to find the spring constant? You are going to find or calculate the gradient of the graph. So we know that from mathematics, we say that the gradient is how steep, or the steepness of the graph. So we know that when calculating the graph, we are going to take the coordinates. When calculating the gradient, we take the coordinates from the graph. So we know that we will take our F1 in math. Let's take in maths for example. We know that we'll be having the graph being y-axis against the x-axis, and you were told that the gradient of any or the given graph would be y2 minus y1 over the x2 minus x1. That says you were going to take the points. Say we take the first point right here, then that would be from this point. The point should be on the graph that you are given. So on this point, taking the coordinates of this point, let's take for example, and let here be 1 2 3 1 2 3. So that says our first x would be, let's say our first coordinate would be 1, 1. From this, we know that the first point, the first value would represent the x values, and the second one would be the y. That says now we have x1 and y1. Again, we will look for another point, say this one, and we are saying then our point would be, our coordinate would be 2, 2. Then this time around, from this second coordinate, this second point, we know that we will be having x, y, and this will be x2, y2. So going back to the equation of the gradient, we are going to substitute the given our values. That says we will have g being the gradient equals to y2. y2 is 2 minus y1. y1 is 1 over x2. x2 is 2. And then we are going to subtract x1, which is 1. Then working out, you will get 1 over 1, which is 1. So that says the steepness of this graph is 1, and that's the gradient. So going back to our Hooke's law graph, that says if you are to calculate the constant, the spring constant, you would look for the gradient. But this time around, what the coordinates, the axis would be labeled with force and the extension of the spring. Therefore, you will be taking the coordinates from the graph. So let's make an example of Hooke's law graph and see how we are going to calculate the spring constant from the graph. The force in newtons, extension in meters. So let's go. If you are asked and if you are given this graph and you are told that this graph is for the certain spring, then you are asked to find the spring constant for that spring. This is how we are going to do it. We are looking for the k. Therefore we said the k is the gradient, which will be the f2 minus f1 over x2 minus x1 being the extension. So let's go on and find our the coordinates. Let's first take this point and let the second point be this point. Let me make the clear sketch for convenience sake. There you go. So from this graph, let's take the points. Let's take this point to be our first point. Then the coordinates would be 3, 3. Then from this we'll be having x1 and f1. The second point will be having, let's consider this point. Then we will be having 1, 1. Then this would be x2, this would be x, this would be f2. So when taking this and substituting in our equation of finding gradient, we will have f2 being 1 minus f1 being 3. Then dividing by x2, which is 1, minus x1, which is 3. So calculating, we get -2 over -2. So remember, we are in mathematics, we say that when dividing a negative by a negative, you get a positive result. Therefore, -2 over -2 would be just 1. So our spring constant would be, from this graph, our spring constant would be 1. So let's move on to the next part, to the next graph. Coming to this graph, you will notice that this time around the graph has the curve in it. So what does the curve say to us? It says that the spring has been stretched beyond its limit of proportionality or elastic limit. Before that, let's define limit of proportionality. We are saying that beyond this point, the force and the extension are no longer proportional. That says the rate at which this extension is increasing is not the same with the one that the force is increasing with. Again, going to elastic limit, we are saying is the maximum amount that an object can be stretched or squashed before it can no longer be able to return to its original shape. That says if you take a paper and you squash it, then if it does not return to its original shape, that says it has reached its elastic limit. So let's go back to our graph. Going back to our graph, that says at this point that I have marked, that says here is the limit of proportionality of the given spring. We are saying that wherever the point at which you start to see or you start to have a curve in the graph of Hooke's law, that says from that point and onwards we have reached our elastic limit. That says the spring cannot it is destroyed or can no longer go back to its original shape or original place. So thank you, that's all for today.